In this part of our tutorial, we will analyze a second-order circuit. Second-order circuit is really similar to our first order, so we can just go ahead and analyze the second-order circuit. And since they're similar, you're gonna get the same idea. Well, let's go ahead and place our parts. This is our DC voltage source. Now let's get our resistor. Now we also need a inductance, hit L. Okay, and also our capacitor. We just need to hit C. We also will need two switches. They are in eval library, so we need to find the eval library and add our eval library. So the first switch is switch to close. The switch is gonna close when the time starts running. Let's place it right there. The other switch is switch to open. Let's go ahead and choose it from place part menu. Let's put it right here. Maybe a little bit lower. So these two switches, as I said, can close and open when the time starts. Let's place the ground and wire our circuit. So here I put values. R is 3 ohms. Inductor is 1 Henry. Our capacitor is 0.5 farads. And we also have our two switches, and our voltage source is 6 volts. Let's go ahead and create a new simulation profile. So I'm just gonna put runtime 6 seconds. That's what I found. Sometimes you have to play with the runtime to get the exact runtime you need to see the response. Also, maximum step size, whatever, as if you want to exact. Okay, let's go ahead and run it. But before, we need to put our probe right over there, because actually we need to find out the voltage of the capacitor, how it's going to change. From what we see right now, it doesn't really make sense, so let's go ahead and close it. What didn't make sense is actually we put F right here, so, and F stands for something else, so that's why if you want to skip units, just go ahead and skip them, like, you know, ohms and farads and henries, so just don't put them. That was our problem actually, so I just discovered it myself. Right now we have pretty nice response here. So we can also, if you have a problem to solve, how to compare the answers. It's really hard because there is no way we can get an equation. So what you can do, you can solve this equation and then solve for the circuit, and then plug your equation in your graphing calculator, and then graph your answer, and then you can compare your answer to the answer you got in PSpice by just like comparing the points actually right there and tracing them on both calculator and your PSpice. That's it. In this part of our tutorial, we'll learn how to do sweep analysis, and also we'll take a look at a frequency response. Let's create a new project. Name it AC Sweep. Let's go ahead and build our circuit. We will use a VAC which is a power source that will generate a wave with an amplitude of 1 volt. It will be a sine wave. Now we'll need a capacitor. An inductor. And a resistor. So you see our circuit is fairly simple. Now let's wire our parts and put our values. Okay, let's go ahead and create a new simulation profile. And we call it AC sweep as well. Now we need to choose the analysis type. We need to choose AC sweep noise. We'll start at a frequency of 10 Hertz and add it at a frequency of 100 kilohertz. We'll logarithmic scale and we'll use the 50 points per decade. Now before we start our simulation, we'll just need to put a probe at a 5.1K resistor. That's where we're going to be measuring our voltage. So as you see, our graph of voltage appears, and we also can add our phase angle here, but before we do it, we need to plot add extra y-axis, and this is our actually graph. You can see it in a little rectangular there. Now we need to add a trace, so we'll need to choose P, which stands for phase. And from the left window, we need to choose our graph, which was VR1, 2. So now you see we have both phase and our magnitude plotted. Let's label them. Okay, we just click on that ABC little thing here to label, and we can put a magnitude in there. Okay, that's how you label plots. Now let's go ahead and add another plot window, and in this plot window we will make a bold plot. Actually, make sure you selected the window when you add one, so like I did, so selection, so my top window is selected. And let's do a bold plot because it's really hard on the logarithmic scale, really hard to figure out how the actually voltage changes. So we just use dB from the right window, and we put insert in there our plot. So, and now we can also label it. Let's do bold label, right, and put it right there. So now let's say we need to copy this our graphs and put it in our Word, so to write a report. So we just go copy to clipboard, we choose it, and we hit OK, and now we can get a Microsoft Word right here and paste all our plots. Okay, here you go. That's how nice and easy it works, and that's how nice and easy it looks. Well, this concludes our tutorial, this part at least. Now let's take a look at a circuit that involves operational amplifier. Let's create a new project. Now let's build a circuit. And in this circuit we'll use an amplifier that is located in eval library, so make sure eval is selected. It's UA741. Let's place it right here and build a circuit around it. So as you see, the circuit is simple. It has three resistors and a 12-volt power source, DC power source. Now let's create a new simulation profile. We'll call it operamp, and we'll select a bias point. So now let's take a look at voltages and currents. Actually, we need to know current that flow through 10K resistor. So our voltage is going to is 84.3 volts, and our current will be 8.4 milliamps. So now this is a positive gain amplifier, so we have 12K divided by 2K gives us 6, plus 1 is 7, and 7 multiplied by 12 gives us 84 volts. Our current is going to be 8.4 milliamps, so it makes sense. Now let's go ahead and look at our problem if we have this amplifier connected to 15 and negative 15 voltage sources, like we have it in the lab. So let's go ahead and run our analysis again. And we will see that now our voltage is limited to 14.6, roughly 15 volts. So this is the sources that limit us to 15 volts. Okay, let's go ahead and take a look at a print preview here. So as we see, we actually have little kind of small kind of picture right there. So, and what we do when we need to print and have a larger picture, we'll just place our schematic somewhere right here, and now we can go to File and select Print Area. After, we can set our print area and define it like this. Now we can go ahead and look at our print preview, and we'll see that our image right now is larger and better visible. So this pretty much concludes our tutorial about introduction into PSpice, and I hope it was very helpful to you. Thank you.